Have you ever written a Python function, passed some data to it, and then stared at your screen wondering why on earth your original list or dictionary just changed? If you've ever felt that confusion, this one's for you. Today, we're going to demystify Python's parameters and turn that confusion into total clarity.
So, here's how we're going to do it. First, we'll tackle that classic parameter mystery that trips up just about everyone. Then, I'm going to show you a super simple mental model, the sticky note model, that will honestly change the way you see Python variables forever. From there, we'll dig into why some data types change and others don't, master all the different parameter types, and then wrap it all up by learning how to design functions that are clear, safe, and built to last.
All right, let's get right into it. The parameter mystery. This is that moment of pure frustration that every single developer has felt. You write what you think is a simple function, you pass it some data, and suddenly that data gets modified somewhere else in your code. It feels like a bug, right? But it's not. It's actually a fundamental core feature of how Python works.
Let's start with a question I am positive you have asked yourself. You've got a list, you pass it into a function to do some work, and when the function is done, you look back at your original list and it's been changed. What is going on there? Why does that happen?
Okay, check out this code. It's a perfect example. We've got a list, my numbers, we pass it to a function that's supposed to remove the big numbers. But, and here's the kicker, when we print my numbers after calling the function, the original list itself has been permanently changed. This is called a side effect, and if you're not expecting it, it can cause some really sneaky, hard-to-find bugs. So how do we solve this thing? Well, we need a better way to think about what variables actually are in Python. I want you to forget anything you've heard about variables being buckets or containers. We're going to use a much simpler and frankly more accurate model, the sticky note model. And I promise you, this is going to be your big aha moment. Now, the really technical, nerdy term for this is call by object reference. What it means is that Python is passing a pointer to the original object in memory, not a copy of it. But let's be honest, that's not super helpful, is it? It's kind of abstract. The sticky note model makes it all make sense. So here it is. Stop thinking of variables as boxes that hold your data. That's just not how it works. Instead, a variable in Python is just a name tag. It's like a sticky note that you slap onto an object, the actual data, that's just floating around in your computer's memory.
Let's really visualize this. When you type my list equals 1, 2, 3, Python does two things. First, it creates a list object, the actual 1, 2, 3, in memory. Then it takes out a little sticky note, writes my list on it, and sticks it right onto that list object. The variable is just the label, not the thing itself.
And this is the absolute key to the whole mystery. When you call a function like myFunctionMyList, Python doesn't make a copy of your list. No way. It just grabs a new sticky note, writes the parameter name on it, say data, and sticks it on the exact same object. So now you have two different names, two sticky notes, pointing to the very same list in memory.
This whole sticky note idea perfectly explains why some data types, like our lists, seem to change inside a function while others, like numbers or strings, don't. This all comes down to a concept called mutability. Let's break down what that means. So here's the big difference. Mutable objects, like lists and dictionaries, can be changed in place. Think of it like a whiteboard. All your sticky notes point to this one whiteboard, and if you change what's written on it, everyone sees the change. On the other hand, immutable objects, like numbers and strings, are like a printed photograph. You can't change it. If you want a different version, you have to create a whole new object and move your sticky note over to that new one, leaving the original completely untouched. But here is the classic gotcha that catches everybody. Look at this code. Inside the function, we use the equal sign. Items equals A, B, C. This does not change the original list. What it does, in our analogy, is it rips the local item sticky note off the original object and slaps it onto a brand new list. The original MyList sticky note, it's totally unaffected. It stays right where it was. So you see, this isn't a bug. It's a design choice, and it's all about trade-offs. Modifying a massive list in place is super efficient. It saves a ton of memory. But if you absolutely need to guarantee that your original data is safe and never altered, you have to explicitly make a copy and work with that instead. The choice is yours, and it really depends on your goal.
Okay, so now that we've got the why down, let's look at the how. Python gives us a ton of different tools for defining our function parameters. And really mastering these is what separates good code from great code. It makes everything cleaner and way more predictable.
Now, when you're defining a function, you can't just throw these in any which way. Python is very, very particular about the order. It has to go positional only first, then your standard positional or keyword guys, then star args to catch extra positional arguments, followed by any keyword-only parameters, and finally, double star kwargs at the very end to scoop up any leftover keyword arguments. Let's look a little closer at each one.
This table is a great little cheat sheet. Positional-only parameters, which you mark with a slash, have to be passed just by their position. Your everyday parameters are positional or keyword. You can pass them by position or name, whatever you prefer. Args is awesome. It just collects any extra positional arguments you throw at it into a handy tuple. Then you have keyword-only parameters, which come after a star. These force the caller to use the name, which makes the code way more readable. And finally, double kwargs does the same thing, but for keyword arguments, packing them all into a dictionary.
Okay, let's put it all together now. Once you understand the sticky note model and you know your parameter types, you can start moving from just writing functions that work to designing functions that are a genuine pleasure to use. Functions that are crystal clear, safe, and super easy for you or someone else to update later on.
Here are the golden rules for designing really solid functions. First off, keep the number of parameters small. If you're going past 5, you should probably rethink things. Use really descriptive names that make it obvious what each parameter does. Always prefer using keyword arguments because it makes the code self-documenting. Use keyword-only arguments for any optional settings. And of course, add type hints and doc strings to make your intentions perfectly clear. I mean, just look at this. This is what we're trying to avoid. Create report, user data, true, false. What on earth do true and false even mean here? You have no idea, right? You'd have to go hunt down the function definition to figure it out. This is just a recipe for future bugs.
Now compare that to this. It's night and day, isn't it? It's the exact same function call, but it's instantly and perfectly clear what's happening. We're including the header, we're not compressing the output. This is what we mean by self-documenting code. It is so much easier for anyone to read and understand at a glance.
And here's the real magic of using keyword-only arguments. They make your code future-proof. So in version 1, our function takes a use cache option. Later in version 2, we decide to add a new timeout option. Because both of these are keyword only, any old code that was calling the function without the new timeout argument will continue to work perfectly. Nothing breaks. This is absolutely essential for building stable, reliable code.
So the next time you sit down to write a function, just ask yourself this: is this function creating clarity, or is it setting a trap for the next developer, which might just be you in 6 months? By keeping that sticky note model in your head and being thoughtful about your parameters, you can write code that isn't just powerful, but is a genuine joy to work with. Thanks for joining me on this deep dive, and happy coding!